All right, guys. So in this last section of Unit 10, we're going to talk about how to know when to use each of the chi-squared tests and when would it be appropriate to use one versus the other, and kind of how can you know based on the data that you're provided, as well as any background knowledge you have about the study itself. So, for example, we're going to look at an article in the Arizona Daily Star, April 9th, 2009, which included the following table. Let's suppose that we decided to analyze this data using a chi-squared test, but we didn't have any additional information about how the data was collected. It isn't possible then to know which chi-squared test is appropriate, and so let's talk about the reason why. So for part A, explain first why it is okay to use age as a categorical variable rather than a quantitative variable. Because remember, one of the key differences between the two was for quantitative variables, it had to make sense to find an average. Well, would it make sense to find an average age? And the answer is yes. So could age be quantitative? Absolutely. But one of the things that we have to keep in mind about age is that age is a discrete quantitative variable. So what we mean by a discrete quantitative variable is that it's already going to be in whole number values. Like when you ask someone for their age, they're going to tell you that they are 15 years old, they are 17 years old, they are 42 years old. With the exception of really young kids and toddlers, you're not going to have someone that says I'm 31 and a half years old, or that I'm 32 years and 3 months old, or whatever the case may be. That's just not going to happen. They're going to give you a whole number year for age. The other reason why it's okay is that it's been broken into categories or bins. And so the fact that it's been broken into these categories or bins means that we can go ahead and proceed with this as a categorical variable, because we're no longer looking at just an 18-year-old, we're looking at a whole group of 18 to 24-year-olds, a whole group of 25 to 34-year-olds, and so on and so forth. So now that we've established that these are both categorical variables, what kind of test are we going to use? Well, in part B, explain how we would know that a goodness of fit test is not appropriate for these data. Keep in mind, goodness of fit is for a single categorical variable. And in this case, we're actually comparing two different categorical variables. We're comparing the age in years to whether or not they use online social networks. And so we can't do goodness of fit in this case because of those two variables. We would have to eliminate one of those two variables in order to do a goodness of fit test. We either have to eliminate the age in years and just look at all of these ages thrown together, how many people use online social networks versus how many do not, or we'd have to eliminate the variable of online social networks and just separate them into these age categories and look to see if there's a difference in the categories of ages. But we have to have just a single categorical variable, so goodness of fit would not work. So that leads us into our next couple questions. What about homogeneity and independence? Well, both of these are used for two categorical variables. So as far as variables go, we're good with them. So how do we know when to use one or the other? Well, that depends on how the data was collected. So in part C and D, we're going to describe how the data could have been collected so that each of those two tests were appropriate. Keep in mind, in order for it to be a test for homogeneity, it has to come from two or more samples. It cannot come from a single sample. Whereas for independence, this has to come from a single sample, cannot come from multiple. So for C, describe how these data could have been collected so that a test for homogeneity is appropriate. We need to figure out how we're going to sample. Well, would it make sense to sample based on those who use online social networks versus those who not? Well, that depends on how they wanted to do it. Could they have maybe gone online to Facebook or Instagram or somewhere and asked the age group of each of those who were on there, and then gone to maybe somewhere else and asked for people who were not using online social networks what their ages were? And sure, I think that's plausible, but I think the more probable way that you could collect the data in order to make it a chi-square test for homogeneity would be to have sampled by age. So in order for C to work, I would say that we would sample each age group individually And then a chi-square test for homogeneity would be appropriate. In other words, we would just go find a group of 18 to 24-year-olds. We'd ask how many use online social networks versus how many do not. And then we would find a similar group of 25 to 34-year-olds and so on and so forth, and basically collect each sample based on age. So how is that different from a chi-square test for independence? Well, for independence, it would have to be a single age group. You would have to sample everybody at once and then divide into categories. And those categories that we'd be dividing into, obviously age would be the primary one, but also whether or not they use social media. In other words, you would just go out and take a random sample of 1,084, in this case, people. And then from those 1,084, you would just record how many fell into each of the age categories, as well as how many fell into the social network and online social network categories. And so that would be the key difference, is how they were sampled. Was it sampled everybody together at once and then divided into those categories? That's where we're going to do a chi-square test for independence, versus if we went out and collected some data from each of the age categories separately. That's where it's going to make sense to do a chi-square test for homogeneity. All right, guys, that is it for Unit 10. Until next time, have a good rest of your day.